Alright, so this one is pretty much the same thing. But we have to figure out, or we have to find a couple of different things. So first off, we're starting with aldehydes and ketones. So aldehydes they're just carbon chains, but they have they're doubly bonded to an oxygen, and they have a hydrogen connected to them. So if you look at all of them, doubly bonded to an oxygen, hydrogen connected. If you look here, doubly bonded to an oxygen, hydrogen here. So we know that this is an aldehyde, and aldehydes always end in "ol," and in "ol," like that. So to find this, first you count the carbon chain. So you start with the carbon that's closest to the doubly bonded oxygen. So we start here, 1, 2, 3, 4. We know 4 is butane, so it's going to be butanol. But we have a couple of things here. So we have, this is 1, 2, we have chlorine here. Remember, with these, they get reduced to an oro, or a rho. So this turns into chloro. And then 3, we have singular line, it's a methyl. And then we wouldn't put the methyl first because we always go in alphabetical order when doing these like branching paths. So that's how you get this first one. Next, start here, carbon, 2, 3, 4. So this is another butanol because of the oxygen and the hydrogen. And then we have a chlorine at 2 and a chlorine at 3. So that's where we get the 2, 3. And it's a dichloro, because remember, if there's more than one, you have to use di. If there's 3, you have to use tri, so on. Next, we have, this is another aldehyde, remember, because of the oxygen and the hydrogen. So we start here, we go 1, 2, 3, 4, 5, 6, 7. So 7, that is a heptanol. Hept is 7. So heptanol. And then remember we count, we have 1, 2, 3, 4, 5, and 6. So 2, 4, and 6, we have a methyl coming out. So that's those numbers, 2, 4, and 6. And we do trimethyl. Next, we have this one. So remember, start from the one that has the oxygen and hydrogen. And since it's oxygen and hydrogen, we're working with an aldehyde again. So we start 1, 2, 3, 4, 5, 6, 7. So this is another hept. Hept is 7, heptanol. And then at 1, 2, and 3, at 3 we have an iodine, which turns into iodo. So 3, 4, 5. 5 we have a bromine, or bromo. And remember, we start with the one that starts in alphabetical order. So we put the bromine first, that's at the 5th carbon. And then the iodine, that's at the 3rd carbon. So that's how you get that one. Okay, and now we're drawing them. So we draw a 2,3-dimethyl octanol. So the octanol, that tells us that we're working with an aldehyde. So our first carbon here has an oxygen connected to it, and then a hydrogen connected to it. And then the octane, that tells us there's 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. And then the 2 and 3, that tells us that there's a methyl at 2. That's a 2. And a methyl at 3, like that. Next, we have pentanol. Remember pentagon, that's 5. So, and enol tells us this is another aldehyde. So the aldehyde, we double bond the O, hydrogen, and then 1, 2, 3, 4, 5. Okay, bends, remember the bends always tells us it is a 6-sided closed shape like this with 3 double bonds in it. Okay, and then the hyde tells us it's an aldehyde. So the aldehyde, you have a carbon that's doubly bonded to an oxygen and then also bonded to a hydrogen. So it looks a little weird, but this is how it's going to look. It bends to a hyde like that. Okay, and then we have 2-methylpropanol. This tells us it's an aldehyde. So you start with the carbon, with the oxygen and the hydrogen, and propanol is 3, so we go 1, 2, 3. And this tells us at 2 there is a methyl. So 1, 2, connected methyl right there. Okay, so there's a difference between common names and IUPAC names. IUPAC is when we use like the numbers, we use we use the numbers, and then like we put everything in like alphabetical order. That's the IUPAC names, but the common names, it wants like a more simplified version. So what this is asking us is it wants these that are connected to this oxygen and C. Also, now we're working with ketones. Ketones, they always end in 1, and they look, it's just a carbon that's doubly bonded to oxygens like this. So you see the carbon, doubly bonded oxygen, carbon, doubly bonded oxygen. They look like this. That's what we're looking for with ketones. So you see a carbon, doubly bonded oxygen, but no hydrogen. This tells us it's a ketone. It's a ketone. We look to the left side. Remember 1, 2. This tells us that an ethyl is connected, because remember 2 carbons is ethyl. But then here we have 1, 2, 3. That tells us it's propyl. But remember, isopropyl is connected in like a Y shape, and this is like a Y shape. If it was normal propyl, it'd be like 1, 2, 3 all in a straight row. But since they like turn into a Y shape, that's how you know it's isopropyl. And then same here, we have to put in alphabetical order. So we have the ethyl, the isopropyl, and then the ketone. Okay. Same here. So first, we're doing common name again. So you look what's on the left side. We have 1, 2, 3, and it's all straight. So that's just propyl. And then 1, 2, 3, 4, 5. That's pentyl. Remember, pen is 5. So we have pentyl, propyl, and then the ketone. And pentyl comes before propyl because PPE becomes before R. So pentyl, propyl, ketone. Okay, here, with ketones, if it's a carbon chain that's 5 or more, we put a number where the oxygen double bond is. And remember, you always got to start closest to the oxygen bond. So we start here, we have 1, 2. The 2, that tells us where the oxygen bond is. We have 1, 2, 3, 4, 5, 6, 7. So since it's 7, we have hept. You always put this "and" for everything, remember that? Hept, and then remember ketone, 1. And then also, we have these 2 lines right here. It's at 1, 2, 3, 4, 5. At 5, you have an ethyl, because remember, ethyl is 2 lines. So that's how we get that one. Keep going. Here, start closest to the oxygen double bond. We have 1, 2, 3, 4, 5, 6. So 6 is hex. So we have hex and the number 1, 2. That gives us our 2. And then we have a couple things here. So at 1, 2, 3. At 3, we have 1 carbon. That's a methyl. 2 carbons. That's a ethyl. And then at 3, we also have an ethyl. So we have di-ethyl and then methyl. And di-ethyl comes in the alphabet before methyl. So we have 3, 3, and 4, 4 diethyl. And then the 3 methyl, and then everything else. So we get that one. Okay, keep going. Right here. Remember, if it's a closed shape, we're using cyclo. So we have a cyclo 1, 2, 3, 4, 5. We have cyclo pent and 1. So the cyclo pent tells us that it's a closed-sided 5-carbon ring. And then the 1, remember, it's where the oxygen bond is. So 1, we start here. So 1, 2, 3. At 3, we have an ethyl because it's 2 lines. So that's how we get this one. We have the 3 ethyl, cyclo, pent, anion. Okay. Same with this one. We have 1, 2, 3, 4, 5, 6. So we have hex, anion. And then if this is 1, 2. 2, we have a bromo. Remember, we always make it O. So 2, bromo, cyclo, hex, anion. You're killing me. Okay, here. So remember, you start nearest the oxygen bond. So we do 1, 2, 3, 3, 4, 5, 6, 7, 8. So oct, the 8, oct, and on, because remember, we only have an oxygen double bond. Remember, oxygen double bonds tells us it's a ketone. If there was a hydrogen connected to this, that would be an aldehyde. But ketones only have an oxygen double bond. So yeah, we have 3 octanon. And then at 2 here, we have a bromo. And then at 2, 3, 4, 5, 6, 7, we have a methyl. And remember, bromo comes first, because first in the alphabet. Then it's the methyl. Then you tell where the oxygen double bond is. Okay, last one. Last one, we have cyclohexanon. Remember, cyclo tells us it's a closed shape. Hex tells us it's a closed shape with 6 carbons. So 1, 2, 3, 4, 5, 6. And the anion tells us a ketone. So we just put an oxygen double bond at the first carbon ring like that. So that's how you draw that. That one's pretty easy. Okay.